Hi everyone, I hope you're okay. And I really hope that guys the videos will keep uploading and helping you out. The boiling points of straight chain alkanes and straight chain alcohols are compared in the table below. We have alkanes and alcohols. All of them are straight chains, ne? Uh okay, so here we are dealing with methane. Here it's methanol. This is ethane. We are dealing with ethanol. How am I sure that you're dealing with ethanol? Because you're told that the first compound has only one carbon, this has only two carbons, this has three carbons, and that one has four carbons, ne? So this will be propane, this will be butane. Are you together? However, this can be propane 1-ol, or it can also be propane 2-ol. The examiner will give us the direction, ne? And then this can also be butane 1-ol, or it can be butane 2-ol, because they never told us that we are dealing with primary alcohols only. So I cannot just assume that I'm dealing with primary alcohols. Are we together? If I'm dealing with primary alcohols only, these will be the IUPAC names of the compounds. Are we together? But if carbon number, if compound, if the last two if the last two compounds are not primary alcohols, then they would be secondary alcohols. Okay. Now let's answer the questions. Explain the increase in boiling points of alkanes as indicated in the table below. Once you add the number of carbons, firstly you are increasing the molecular size of your compound and also the surface area of your compound. Are you together? So whenever you answer, you can simply say that's an increase in the molecular size and the surface area makes the compound to have stronger intermolecular forces. Are you together? So once it has stronger intermolecular forces, we know that more energy will be required to separate bonds, and hence the boiling point is higher. Are you together? Once you increase the chain length, you are increasing both the surface area of the compound and the molecular size. Once you increase those two, you are definitely increasing the intermolecular forces between the compounds. And once you are doing that, obviously you will require more energy to separate the bonds of alkanes that has stronger intermolecular forces, and hence the ones with more surface area and a higher molecular size will have a higher boiling point. Okay, now we are supposed to explain the difference between the boiling point of an alkane and an alcohol having 3 carbon atoms per molecule by referring to the type of intermolecular forces. Okay, alkane and alcohol that has 3 carbon atoms. We will be dealing with propane, and then for alcohols it can be either propane 1-ol or propane 2-ol. It doesn't matter, né, guys? Since the examiner didn't specify, then we are okay as well. We'll simply say that alkanes have London forces which are regarded as the weakest in the intermolecular family, and then alcohols have hydrogen bond which is regarded as the strongest hydrogen bond, né? So that's why an alcohol with 3 carbons have stronger intermolecular forces. My battery is low. Okay, and then hence more energy will be required to separate the bonds of the alcohol. Are you together? And hence the alcohol has a higher boiling point. Remember that, guys, the stronger the intermolecular forces, the higher the boiling point. Yeah, the reason the boiling point is higher on alcohols, it's because it has stronger intermolecular forces. Okay, now let's go to 3.3. Does the vapor pressure of alcohol increase or decrease with an increase in the number of carbon atoms? Remember that, guys, vapor pressure and alcohol are inversely proportional. When the boiling point increases, it simply means that the vapor pressure will decrease. Are you together? So we can see that by adding the number of the number of carbons on the parent chain, we are increasing the boiling point. That means vapor pressure will be decreasing. Okay, how will the boiling point of 2-methyl propane compare to that of its chain isomer? Its chain isomer will be butane, né? The boiling point of methyl propane and butane will be different. That of butane will be higher. Why? Because butane has butane is like this. It has more carbons on the parent chain, and then methyl propane is just like this. Okay, write down higher than, lower than, or equals to give a reason for the answer by referring to the structural difference. Methyl propane, its boiling point will be lower than that of a chain isomer. Why? Because methyl propane is branched and its chain isomer is just a straight chain. Because methyl propane is branched and its isomer has a greater surface area. No, man. Yeah, because methylpropane is branched, that's the reason. Or you can say that because methylpropane has lesser surface area. It's up to you. Do not stretch it. It's just simple as that, no? Okay, that's how, guys, we're supposed to tackle this question. I really hope the video helped you out. Thank you for your time.